Hi everyone, welcome to YourPedia platform friends. Notification has come out from 19 posts in Assistant Environmental Engineering in Telangana states, and it is expected that exam will be conducted on September month. So you have sufficient time because June, July, August and September month, but we are not considering the September month. So June, July and August, so these durations we have sufficient time. So we will try to cover your entire syllabus, or no doubt we will cover entire syllabus within these durations. And also friends, module has started, module has launched, classes has been started, and from next of week we are going to increase the durations of the classes because we are going to cover entire syllabus within these durations. So we have to increase the durations also, right? From next of week we will increase the durations of the classes. And one more point friends, if we compare with the Andhra Pradesh Pollution Control Board, and this syllabus for the paper 2 is almost similar. That is a technical part, and syllabus is almost similar for both the exams. And if we talk about the paper 1, so 50 to 60% syllabus is matching with Andhra Pradesh Pollution Control Board, right? And one more point friends, as you all know that YourPedia is the dedicated platform who is covering different state pollution control board, and also we are covering the CPCB, right? Friends, in the past we have covered like Haryana Pollution Control Board, Punjab Pollution Control Board, Uttar Pradesh Pollution Control Board, Rajasthan Pollution Control Board, and also you can say Odisha Pollution Control Board. And recently, and we are covering this Andhra Pradesh Pollution Control Board, and just we have launched this Telangana Pollution Control Board. Friends, our module is the dedicated module because precise content will be delivered to you, no extra information, or you can say because environmental engineering, if we talk about our subjects, very wide domain it is, but we are not going to cover entire topics. We will study only our exam point of view. So very precise content will be delivered by us. So that's why we are saying our module is the tailor-made module friends. So classes already started. If you have any doubt regarding the classes, you can contact us. Now today I am going to cover one topic, that is quality of the water. This is the water pollution topic. So that is very important. 2 to 3 questions you will see in your exam. So I am going to cover this topic, quality of water. But in this quality of water, I will tell you that different quality parameters we have: physical, chemical, biological. So just I am covering only 2 parameters. That one is the suspended solids, another one is the color. That is the physical quality parameters. So friends, let's start our topic. So first of all, if I talk about the quality of the water friends, right? So what is the purpose of assessing the quality? If I ask you that you have any source and you are going to supply this water from this source to any community, right? So let's take an example like this one friends. So let us suppose there is some source of water is there. Let us suppose a river is there. So this river we are considering it is a source, right? From this river we are going to supply the water in our community. This is our this is community, this is our city, and our city required water, our community required water. So this demand will be satisfied, and the source of the source of the water we have river. Let us assume this river we have a source. We can have another source also, like groundwater also we can use, reservoir also we can use, right? So we have a different sources. Just I am taking an example like river, you have a source. So from this river you are supplying the water into the community. Now my question to you, can you use this river water directly without being treated, without any treatment? So answer will be no. We know that this river water consists some parameter that is not desired for us, that is not desirable for us, you can say, right? Because if we consume that water, it will create problem, right? So what are the problems that will be created? So we will discuss one by one each. So this river water we cannot consume directly without the treatment, right? Because it consists those parameters which are not required by us. So those impurities are present. So we have to remove the undesirable parameters, undesirable impurities from the river. So how can we remove that? In that case we have to design our treatment plant. So we design our water treatment plant. So after the treatment we supply water to the community. So in between we are designing our water treatment plant. That is very important unit, right? But before the treatment we have to assess the quality of the water. So here friends, we are going to assess the quality of the water. That is very important, because if we don't know the quality of the voter, we cannot treat our voter sample, right? So to treat the voter sample, we have to assess the quality of the voter. So that's why initially we will assess the quality of the voter. So friends, quality, if I ask you how will you find the quality of the voter, then answer will be, sir, quality of the voter will be found by taking the help of certain quality parameters, and those parameters which helps us in assessing the quality, in assessment of the quality of the voter, that are known as the voter quality parameters. So friends, quality of the voter is found with the help of some parameters that are termed as voter quality parameters, right? So basically these voter quality parameters are helping us in identify, or you can say in the identification of the voter quality, right? If I say that 1 liter sample of water you have and just consume it, you can say we cannot consume without checking the quality. So we have to check the quality of the voter. How will you find the quality? How will you assess the quality of the voter? So you will take help of certain quality parameters that are termed as voter quality parameters, right? So now these voter quality parameters, friends, these are classified as physical quality parameter, chemical quality parameter, biological quality parameter. So we have 3 different quality parameters. One is physical, one is chemical, one is biological. If I ask you what is the meaning of physical quality parameters, then answer is physical quality parameters are those parameters which indicate physical quality of the voter. That indicates physical quality of the voter. So what is the meaning of physical quality? If I ask you what is the physical quality of this 1 liter sample, it is the 1 liter sample, let us assume it is 1 liter water sample. What is the quality, what is the physical quality of this 1 liter water sample? What is the meaning of physical quality? So friends, physical quality means if any parameter you can sense by any of your senses. If any parameter you can sense by any of your senses, so that parameter will be physical quality parameter. That parameter will be termed as physical quality parameter. Let's take an example. Suppose that in our 1 liter sample, some particles are present which can be seen by naked eyes. So some particles are present. So these particles are present and we can see that. So these particles will be the physical quality parameters, because these particles indicating the physical quality of the water, because we can sense that. Suppose that in our water sample there is some color. Let us suppose our water sample is of red color. Just example I am saying, just I am taking an example. Let us suppose our water sample is of red color. So again you can sense that color, you can see that color. So again it will be physical quality parameter. Suppose that from this water sample some smell is there, some smell is coming out from the water, some odor is coming out from the water. So this taste may be present in our water sample. So this taste and odor will also be the physical quality parameter, right? One more parameter, you can say temperature. If you touch your water sample, you may feel that it is warm or it is cold, right? So further we can say that temperature is also the physical quality parameter. So basically friends, I am trying to say that physical quality parameters are those parameters which indicate physical quality of water. Physical quality of water. What is the physical quality? Physical quality means those parameters which can be sensed by any of our senses. So if we are able to sense any quality from the water sample, so that quality will be termed as the physical quality, right? That quality will be termed as the physical quality, friends. So physical quality parameters, these are the parameters that indicate physical quality of the water, and it can be sensed by any of our senses. It can be sensed by any of our senses. So physical quality parameter is the water quality parameter, right? There are the 3 water quality parameter. One is the physical quality parameter, second is chemical quality parameter. Physical quality parameter indicating the physical quality, and same you can say chemical quality parameters indicates the chemical quality of the water. Our water sample, in our water sample we are observing that no color is there, no odor is there, no taste is there, and you can say no suspended solids are there. So can we consume that water? Maybe you are saying that physical, you are observing the water sample and you are saying, sir, no taste is there, no color is there, no suspended particles are present, because we are not observing any particle, so no suspended particles are present, right? So can we consume that water? That again answer will be no. Why? You have to first check the chemical quality. If your water is chemically pure, then you can say that we can consume our water, right? So chemical quality parameter that indicate chemical quality of the water. Chemical quality parameters indicates chemical quality of the water. So if we want to assess the chemical quality of the water, we have to take the help of chemical quality parameters. And if we want to assess the physical quality of the water, we have to take the help of physical quality parameter. In the same way, friends, another parameter we have biological quality parameter. Biological water quality parameter, friends, these parameters are helping us in the identification of the presence of microorganism. Maybe microorganism present in our water sample. So if any microorganism is present in our water sample, so we cannot consume that water, because if we consume that water, then problem will be waterborne disease there. So due to the water, some disease will be there that are termed as the waterborne disease. So we have to ensure first that there is no microorganism is present in our water sample. So to find that, we have to check the biological quality. So biological quality parameters helping us in the indication of the biological quality parameter, they indicate biological quality of the water. So biological quality parameters indicate biological quality of the water, right? So again, quality of the water, you are going to find the quality of the water, and it will be found with the help of certain parameters. Those parameters will help you those parameters will help you in assessment of the water quality, and those parameters are termed as water quality parameters. In the water quality parameters, these are classified as physical quality parameter, chemical quality parameter, biological quality parameter. Physical quality parameter indicates physical quality of the water, chemical quality parameter indicates chemical quality of the water, and biological quality parameters will indicate the biological quality of the water, right? So first, friends, we have physical quality, but before this physical quality parameters, some points are written here. First is that potable water. We have different types of water, friends. We have different type of water. As we will discuss this environmental engineering, or you can say our water pollution topic, I will tell you the different types of water we have. That first, that potable water, let us suppose potable water is, what is the meaning of this potable water? Potable water, you can say, and if I say you that different names of the water, like you have heard, like raw water, waste water, brackish water, pure water, distilled water, potable water, wholesome water, right? So there are different types of water, right? So one, like potable water. What is this potable water? What is the meaning of potable water? So potable water means it is the fit for drinking. The water which is fit for drinking, that is termed as the potable water. Very important point, potable water. And what is the wholesome water? What is the meaning of wholesome water? Wholesome water means that our water sample is not chemically pure. Our water sample is not chemical pure, but it does not contains anything harmful to human health. Wholesome water is that water which is not chemically pure, but potable water is chemically pure. Potable water is fit for drinking. Wholesome water is not chemically pure, but it does not contains anything harmful to human health. That means if you consume this wholesome water, then we are saying wholesome water is not chemically pure, but it does not consist any harmful ingredients, or you can say any harmful ingredients, or you can say any harmful parameters, any harmful parameters, like so it does not contains anything harmful that will be harmful for the human health, but you can consume that. So just remember these two water. Potable water, it is fit for drinking. Also wholesome water we can consume, but according to the exam you have to click the answers. So in the exam, potable water, it is fit for drinking, and if it asks about the wholesome water, then you will say that it is not chemically pure, but also it does not contain anything harmful to the human health, right? One another point friends, if we talk about the code, so we have a code, this IS 10500, this we have a code, and this code is the drinking code. This code we say it is our drinking code. This is code, we have drinking code. What is the meaning of this drinking code? If I ask you that this river, right, I told you this treatment plant is being designed by us in order to remove the impurities. We are going to remove the impurities from the water sample so that we can consume that water. But in the community we are supplying the water and we want to consume that water, and our water sample, this river source, our water sample consists some parameters which are not desirable for us. So we have to remove those parameters. How we remove? So the parameters will be removed in the water treatment plant. But the question mark is there, which amount, what amount of parameters you are going to remove? Are you going to remove all the parameters, or you can say 100% parameters are you going to remove? If you remove 100% parameters, that it will increase the cost of the treatment plant. Yes or no? So friends, there is a code, drinking code is there, and according to drinking code, different parameters have different limits, and these limits are set by this drinking code 10500. If this drinking code says the acceptable limit of the turbidity is 1 NTU and our water sample having the turbidity 5 NTU, so we have to remove the turbidity, and we make our water sample such that turbidity of that water sample comes out to be 1, from 5 to 1. So we have to treat our water sample accordingly, right? So these parameters, these limits are set by this code, drinking code 10500. So in this topic, quality of the water, if any parameter you have, so if in the question asks what is the acceptable limit for the color, then you will mark your answer according to this code. This code will be preferred, right? So remember this point. This code may or may not be mentioned in the question. If it is mentioned, it is well and good. If it is not mentioned, again you will report your answer according to this code. So this is very important code friends, right? 10500, 10,500 code, 2012, this is very important code. So remember, just remember this point, drinking code. So potable water, it is fit for drinking. Wholesome water, it is safe. And for if we talk about the drinking code, we have IS 10500. This is our drinking code. Now first, physical quality parameter. As I told you, physical quality parameters are those parameters which indicates physical quality of the waters. Physical quality means the quality which can be sensed by any of our senses, right? Physical quality means the quality which can be sensed by any of our senses. By any of our senses, that is known as the physical quality, right? In this physical quality, we have first physical quality parameter, that is suspended solids. In this physical quality, first quality parameter, we have suspended solids. As the name suggests, suspended solids, the solids which are present in our water sample and that are in suspensions. All the are the solids. Let us suppose you have this water sample. In this water sample, some solids can be seen by naked eyes, but also some solids are present in our water sample that we cannot see by naked eyes. Yes or no? Some solids are also present in our water sample because their particle size is very less. We cannot see those particles by naked eyes. And some particles having more size, greater size, large size, so you can see those particles by your naked eyes. And those particles will be in suspension in your water sample. So that means we are classifying these solids. If we talk about the total solids, in our water sample, so you will say, sir, if we talk about total solids, so in the total solids in our water sample, some solids we can see by naked eyes and those particles will be in suspension in our water sample. But some solids having very lesser particle size which cannot be seen by naked eyes. Yes or no? So that means we are saying the particles which are in suspension, which you can see by your naked eyes, that are the suspended solids because they are in suspension. And some solids are there which you cannot see by your naked eyes and those particles which having very lesser size, and those particles are termed as the dissolved solids. Those particles are termed as the dissolved solids. So in our water sample, total solids will be sum of suspended solids and dissolved solids, right? So remember this point. In our water sample, total solids will be the sum of suspended solid plus dissolved solids. So in our water sample, total solid is the sum of suspended solids plus dissolved solids, right? So suspended solids, as I told you, this will be physical quality parameter. Why? Because you can see those particles, so that's why this will be, you can sense the quality, you can see those particles. So suspended solids becomes the physical quality parameter, friends, and you cannot see dissolved solids. So dissolved solids is not the physical quality parameter. Dissolved solids becomes the chemical quality parameter. We cannot sense the dissolved solids in our water sample, but we can sense suspended solids. So that's why suspended solids becomes the physical quality parameter. So in our water sample, total solids consist suspended solids plus dissolved solids, right? Suspended solids plus dissolved solids. So this point. Further, on the basis of nature also we have classified these solids. In our water sample, if I take some example, let us suppose if we talk about the example of river. This river is flowing and it also carries some particles along with that, and these particles you have heard, right? It consists clay particles, silt particles, sand particles, gravel particles, right? Some forest soil it consists, some organic matters is consist, or you can say some plants are there, some animal wastes are there. So basically on the basis of nature we have classified the solids as organic solids and inorganic solids. So in our water sample, whatever the amount of solids are present, on the basis of nature we have classified the solids. One is organic solids, another one is inorganic solids. So if we talk about these solids, that means total solids, these total solids can be organic in nature, as well as it can be inorganic in nature. So some solids will be organic and some solids will be inorganic. Let me give you some examples of inorganic solids, friends, and the examples of inorganic solids like sand, silt, clay, oil, grease. These are the inorganic solids. So if I write here some examples of inorganic solids. So in our water sample, sand is present, silt is present, clay is present, oil is present, grease is present, and ferric hydroxide, some chemical names, ferric hydroxide precipitate. So these are the precipitates. Calcium carbonate, also precipitate, right? Magnesium hydroxides, these also the precipitates. It means precipitates. Now what is the meaning of this precipitate? We will discuss later on, right? So these precipitates you will observe in your water sample. So these are the solids, these are the inorganic in nature. These are the solids, these are inorganic in nature. These are the solids inorganic in nature. And some solids are organic in nature, and examples of organic in our water sample, let us suppose methane is there. In our water sample, methane is there, glucose is there, C6H12O6, glucose is there. In our water sample, benzene is there, C6H6. Phenol is there. In our water sample, phenol is there. In our water sample, algae is present. In our water sample, plankton is present, etc. Many more compounds are also there. So in our water sample, organic particles are also present, inorganic particles are also present, right? Only these two nature of particles are present. Some solids will be organic in nature and some solids will be inorganic in nature, right? So friends, total solids, suspended plus dissolved solids, and on the basis of nature it can be organic, it can be inorganic. Some suspended solids which are in suspension, some suspended solids may be organic and some suspended solids may be inorganic. Let me give you an example. If I say that these sand, silt, clay, these particles are in suspension. These particles are in suspension, right? These all particles are in suspension. These all particles are in suspension. So these all are the inorganic suspended solids. These all are the inorganic suspended solids. Inorganic suspended solids. And these particles, like, and these are the organic solids, but in these organic solids, some solids are in suspension, some solids are in dissolved forms. If I tell you that this glucose C6H12O6 CH4 methane, right? So C6H phenol is there, right? C6H6 is there. So these particles in dissolved form. These particles in dissolved form. So these are the organic particles, and further it is in dissolved form. So we can say these are the organic dissolved solids. But if we talk about algae, if we talk about plankton, these particles are organic particles, but these are not in dissolved form. You can see by your naked eyes. So these particles are the organic suspended solids. So basically I am trying to say that suspended solids further can be organic nature. So we can write organic suspended solids, and some are inorganic suspended solids. And in dissolved solids, some solids are organic dissolved solids and some are inorganic dissolved solids. Right? So these all are the examples of inorganic suspended solids. These all are the examples of inorganic suspended solids. Friends, sometimes in exam question asks that which of the following solids is the organic suspended solids. Sometimes question asked in the exams. So these are the inorganic suspended solids, and here the boxes, the solids which are written in the box, these are the organic dissolved solids, and here algae and plankton, these are the organic suspended solids. If I take example of inorganic suspended solids, for inorganic suspended solids, like you can say for inorganic suspended solids, let us suppose magnesium carbonate, magnesium sulfate. So these are the etc. Many more compounds are also there. So these are the inorganic. These are the inorganic dissolved solids. These are the inorganic dissolved solids. These are the inorganic dissolved solids. Magnesium carbonate, magnesium sulfate. So these are the inorganic dissolved solids. So inorganic dissolved solids, right? Organic dissolved solids, inorganic suspended solids, and organic suspended solids. So these are the some examples. So friends, conclusion is this: in our water samples, solids are present, and these solids are classified as suspended solids and dissolved solids, and on the basis of nature it is further classified as organic as well as inorganic solids, right? Now, so this basic concept is total solids are of two types. One is suspended solids, another one is dissolved solids, and on the basis of nature we have classified that organic matter and inorganic matter. These solids are classified as organic solids and inorganic solids. Organic matters, basically you are observing here that sir, all the organic substance consist carbon, hydrogen, oxygen, but it is not necessary. It is many other elements are also there, like nitrogen, right? Nitrogen, phosphorus, sulfur, right? So basically what happens, if carbon, hydrogen, oxygen, sulfur, phosphorus, nitrogen, etc., they makes bond with each other. Let us suppose one compound is there, C, and mole of carbon is A, and hydrogen, mole of hydrogen is B, oxygen, mole of hydrogen is C, nitrogen, mole of nitrogen is D. So this compound is there, and this compound consists carbon, hydrogen, oxygen, nitrogen. So any compound which consists carbon, hydrogen, oxygen, or carbon, hydrogen, oxygen, nitrogen, that means these elements or these atoms making compounds with each other. These atoms after the joining making compounds with each other. So that compounds are termed as the organic substance. But we have not to cram this point. We have not to cram these points because we have an example of CO2. In this CO2 carbon and oxygen is there, but this is the inorganic substance. So how will we differentiate it? But as I told you that here some examples I have written here. But as the topic continues, as we will discuss many more substances, so with respect to the time, I will tell you which solid is organic, which solid is inorganic, and very easily you will understand which type of solid is organic and which type of solid is inorganic. Right? So with respect to time, we will discuss entire things. Right? So remember this point, CO2 is the inorganic dissolved solids. It is the inorganic dissolved solids. Right? Further. Now this organic matter, if we talk about this organic matter, we know this organic matter, we also classified organic matter as biodegradable organic matter and non-biodegradable organic matter. Now what is the meaning of this? I am saying this, we have classified organic matter. One is biodegradable organic matter, second one is non-biodegradable organic matter. Right? Friends, one point you have to remember, that is whenever the organic matter is present in our water sample, so microorganism will also be present there. Why is it so? Because in our organic matter, some organic matters are biodegradable in nature and some organic matters are non-biodegradable. We are classifying further. We are classifying the organic matters further, that some organic matters are biodegradable, some organic matters are non-biodegradable. What is the meaning of biodegradable and non-biodegradable? We know that organic matter we have, and let us suppose this organic matter is this one. Carbon-carbon bond is there. This also the organic matter, carbon-carbon bond is there. Here it is the single bond, here it is the triple bond. Both are organic matter because in both these substances carbon atom is there. And I told you that any compound is there in which carbon atoms, oxygen, hydrogen, etc. These are making compounds, right, by joining with each other. So if carbon-carbon is there or carbon-carbon is there, somewhere it is the single bond, somewhere it is the triple bond. Both are the organic matter. And microorganism, and friends, microorganisms, micro means small organisms. Microorganisms are there. Microorganisms will be there. What happens? These microorganisms will decompose this organic matter. Microorganism will decompose this organic matter. Decomposition means breaking of bond. Microorganism will break this bond. Which bond? Carbon-carbon bond. When microorganism break this carbon-carbon bond, after breaking this bond, carbon atom will be free. And this carbon atom will be consumed by this microorganism. That means microorganism consume carbon from the organic matter. And how will it consume? First, it will break the bond. So when bond will be broken by microorganism, so we are saying that organic matters are decomposed by action of microorganisms. So biodegradable organic matters are those organic matters which are decomposed by action of microorganisms. And here meaning of decomposition is to break the bond. Now question mark is there, sir, why microorganism is breaking this bond? What is the reason? I told you that after breaking the bond, carbon atom will be free and microorganism will consume this carbon. Why is it so? Because carbon is the source of energy for the microorganism. Carbon is the source of energy for microorganism, friends. Our source of energy is also the carbon. We also consume the carbon. We human beings also consume the carbon, but we consume carbon in the form of carbohydrates. We consume roti, chapati you can say. We consume that roti, and in that chapati carbohydrates are there. And these carbohydrates consist carbon, so that we get energized, you can say. So we also consume carbon because carbon is essential for us. Carbon is the source of energy for us. So we consume carbon in the form of carbohydrates. Similarly, microorganisms also requires carbon because carbon is the source of energy also for them. But they consume carbon from the organic matter. So the organic matters which are decomposed by the action of microorganisms. Decomposition is breaking of bond, because when bond break, then only carbon atom will be free, and then only microorganism will consume that carbon atom. Yes or no? So organic matters which are decomposed by the action of microorganisms, those are termed as the biodegradable organic matter. And certain organic matters are also there. The organic matters which cannot be decomposed by the action of microorganism. Let us assume this triple bond. Here microorganism, if break this bond, it will take too much time. That means for breaking of this bond, to make the carbon atom free from this compound, to break this bond, microorganism require too much time. Too much energy. So it will take time, very much time, very large duration, very long duration. So we are saying that these organic matters cannot be decomposed by the microorganisms. So some organic matters are decomposed by the action of microorganisms, but some organic matters are there which cannot be decomposed by the action of microorganisms. So those organic matter which cannot be decomposed by the action of microorganisms, those are termed as the non-biodegradable organic matter. And biodegradable organic matter, friends, the organic matters which are decomposed by the action of microorganisms, right? So listen, this biodegradable organic matter decomposed by action of microorganism. And what is the meaning of decomposition? Is breaking of bond. And who is responsible for this breaking of bond? Microorganism. Microorganism is breaking the bond such that carbon atom will be free and it will consume that carbon, because carbon is the source of energy for the microorganism, friends. I hope it is clear to everyone, right? So microorganism will decompose, or you can say microorganism will break the bond. So organic matter which are decomposed by the action of microorganisms are termed as the biodegradable organic matter, and such organic matters which are not decomposed by the action of microorganisms, those are termed as the non-biodegradable organic matter. So they cannot be decomposed by action of microorganism. Why? Because bond energy is higher. Why? Microorganism require too much time, too much energy for breaking this bond, and here time is very less. Why is it so? Because bond energy. Here bond energy, because it is a triple bond, so bond energy is high. When bond energy is high, so microorganism cannot decompose easily. Yes or no? Right? So sir, how we will differentiate that which organic matters are biodegradable, which organic matters are non-biodegradable? So again, I will tell you later on in our later classes that how we differentiate which organic matter is biodegradable and which is non-biodegradable. Right? And basically this organic matter is not differentiated by us. It purely depends on the microorganism. Let us suppose in our water sample, friends, some organic matters are there, and now we are sitting here and now we want to find which, let us suppose two types of organic matter are there, and we want to find which organic matter is biodegradable and which organic matter is non-biodegradable. It is not in our hand. So how will we differentiate in that case? Then microorganism will help us. So in the given time, if microorganism is able to decompose the organic matter, suppose that microorganism is decomposing both organic matter, so it means both organic matter will be biodegradable. But in that case, suppose that none of the organic matter is decomposed by the microorganism, so it means both organic matters are termed as the non-biodegradable organic matter. Right? So friends, only microorganism will tell us that which organic matter is biodegradable or which is not non-biodegradable. Right? And this topic which I am explaining you, that will help us in our future topics, right? And more points, more concepts are also there, which I will tell you just one by one, right, as our topic continues. Now, so till up to here, what I told you that in our water sample, total solids are there and total solids, sum of suspended solids and dissolved solids. And in some suspended solids, some solids are organic suspended solids, some solids are inorganic suspended solids. Some solids are organic dissolved solids, some solids are inorganic dissolved solids. Examples are written here, friends. Examples are written here. Algae, plankton are the organic suspended solids. Calcium carbonate, silica oxide, silica dioxides, magnesium hydroxide, Fe2O3, ferric oxides. These are the inorganic suspended solids. C6H12O6, it's a glucose. It is the organic dissolved solids. Inorganic dissolved solids like magnesium carbonate, CO2, carbon dioxide, these are the inorganic dissolved solids. Yes or no? Further, organic particles are classified as biodegradable and non-biodegradable. Now, if I say one point, in our water sample, non-biodegradable organic matter is present. In our another sample, biodegradable organic matter is present. Now listen carefully, friends. I give you two samples. One sample consists biodegradable organic matter, another sample consists non-biodegradable organic matter. And if I ask you which sample consists microorganism, then answer is very clear that sir, microorganism will be found in that sample which having organic matter of biodegradable in nature. So that this sample consists biodegradable organic matter, that means in this sample microorganism will be present. But sir, in this sample non-biodegradable organic matter is present, so no microorganism will be there. Right, friends? Now our next topic, next point is that we are discussing about the suspended solids. Now how we measure the suspended solids, because we are going to remove the suspended solids in the water treatment plant. But before removing in water treatment plant, you have to measure that in what amount suspended solids are present in our water sample. You have to measure that. So how will you measure? How will you measure it? So we have a technique for the measurement of suspended solids, and that technique name is very important. And the name of that technique is known as the gravimetric technique. Gravimetric technique, friends. So by this gravimetric technique, we measure amount of suspended solids. In what amount suspended solids are present in our water sample. So we measure this, and the technique name is gravimetric technique. Here gravimetric, you can break this word gravimetric. Gravi means gravity, metric means measurement. Gravity means weight. That means you will tell the suspended solids in terms of weight. You cannot, you will not say, sir, that in our sample 10 particles are present, 20 particles are present. Never. You will report your answer in terms of concentrations. How? I will tell you. Now, suppose that this water sample you have considered 200 ml. Just take an example. We have considered this 200 ml sample, friends. We have taken this 200 ml sample, and in this 200 ml sample, total solids are present. Total solids are dissolved solids plus suspended solids. Dissolved solids plus suspended solids. These are the total solids, right? So some solids are in suspension, some solids are in dissolved forms. Now what we do? Now we have taken one filter. We have one filter. We have taken one filter, right? One filter paper we have. Glass fiber filter generally we use. So we have some filter paper we have. Now what we do? This water sample is being filtered. This water sample is being filtered. So when this water sample is being filtered through this filter paper, so what happens? The water will move through this filter paper. Yes or no? The voids which are present in the filters, voids having very lesser size. So from those voids, water will pass. And along with this water, dissolved solids also pass. Yes or no? But on the filter paper, some solids will be retained. On the filter paper, some solids will be retained. These solids, we can say, sir, these solids having size greater than filter voids. This filter paper we have, and filter paper having voids, empty space void, and voids have very lesser size. Voids have very lesser size. If voids are of more size, bigger size, then when we filter our water sample, so the impurities, the suspended particles which having size lesser than voids, they will also move, they will also penetrate, they will also pass through this filter. But we choose our filter that having voids of very smaller size, very lesser size. So in that case, we are saying only dissolved solids can penetrate, only dissolved solids can pass through this filter sample, and the solids which are retained on these filters and the solids which are retained on these filters are suspended solids, are suspended solids. So we are saying the solids which retained on the filters is termed the residue on filter. It is the residue on filter. It is termed as the residue on filter, and residue on filter consists suspended solids, and residue on filter consists suspended solids. So this is the suspended solids are present here, right? And this mass of this filter paper we have on which we are taking the residue. So this empty mass of the filter we are considering is the M naught. M naught is the empty mass of the filter, and now residue, or you can say now these particles have also retained their suspended solids. Now total mass is named as M1. Total mass we are saying M1. If I ask you, M1 is the total mass. Mass consists mass of the empty container, or you can say mass of the filter paper plus residue. So M1 is the mass of filter, empty filter, you can say mass of empty filter plus residue, and this residue consists suspended solids plus some amount of water also. Yes or no? Yes or no? Some amount of water will also be retained on the filter paper along with these solids. Yes, no doubt, mostly water passing through this filter paper, but these solids will also carry out, some water particle will also retain on these solid particles, right? So on this filter paper some amount of water will be there. You can say that water will be trapped, or you can say water will be held by particles by physical force of attraction. So some amount of water will be there, no doubt in that case. So this residue plus mass of empty filter is the M1. Now what we do, we heat this residue, and in this residue suspended solids and water is present. We heat this residue. When we heat, and the temperature is 104 degrees Celsius. Remember, the temperature is very important, friends. The temperature is 104 degrees Celsius. At 104 degrees Celsius this residue is heated. When we heat our residue, all the water will evaporate. And only suspended solids will be there. Only suspended solids remains left. So now we measure the mass. Of suspended solids. After filtration we have M1 mass. After filtration we have M1 mass. M1 mass is the mass of empty filter M naught plus residue. Now we heat this residue. When we heat this and also when we are heating the residue, filter paper is also there, container is also there, because the residue is obtained on the container, and a container having empty mass is M naught. So if we are saying we are heating the residue, means container is also present there. So from this residue water will evaporate. Now we have mass, and this mass is M2. Now we are saying mass is M2. This mass of M2 is mass of the container plus only suspended solids, right? And now we can find the mass of suspended solids. So suspended solids will be M2 minus M1. Suspended solids is M2 minus M1. So this is the calculation, friends, which we do in our laboratory to calculate these suspended solids. So our 200 ml sample consists this much amount of suspended solids, and this much amount of suspended solids, you measure the weight of that suspended solids, and the weight of suspended solids, let us assume it comes out X milligram. We can measure, we have a weighing machine in our lab, we can measure the mass of the suspended solids, and let us assume the mass of the suspended solids is X milligram. So what we are saying, our 200 ml sample consists X milligram suspended solids. What we are saying, 200 ml sample, 200, let me change the color, 200 ml sample of water, 200 ml sample of water consists suspended solids X milligram. Yes or no? We are saying 200 ml sample of water consists suspended solids of X milligram. Is it clear? Now Now listen very carefully. If you have 200 ml sample and it consists x milligram, and let us suppose if you have let just take an example, 20 mld water, 20 million liter water. If you have 20 million liter water, what is the amount of suspended solids? Again, you are going to tell in you are going to report your answer in terms of mass, in terms of weight. So what is the value, what is the amount of the suspended solids in 20 million liter water, 5 million liter water? So to make the calculation easier, what we do in that case, we report our answer in terms of concentration. If 200 ml sample consists, if 200 ml sample of water consists suspended solids x milligram, so 1000 ml, that means 1 liter. 1000 ml, that means 1 liter. So we can say if 200 ml sample of water consists suspended solids x milligram, so 1000 ml, yani 1 liter sample, 1 liter sample consists suspended solids of x divided by 200 multiply 1000. So the answer will be 5x. So answer will be 5x. So if 200 ml sample consists suspended solids x milligram, so we can say 1000 ml sample of water consists suspended solids 5 times of x. Unitary method, very simple point. So concentration of suspended solids in our water sample is 5x milligram per liter. So we are saying that 1 liter sample consists suspended solids 5x milligram. So if 1 liter sample consists suspended solids 5x milligram, and if you have 50 million liter water, it will consist suspended solids 50 million liter multiply 5x value. That means 250x milligram suspended solids. 50 million liter, no? It's 50 million liter. So 50 million liter, 50 million liter, that means 50 million liter. So you have to convert into liter. 50 multiply 10 raised to power 6. This liter of water you have, just multiply it with 5x milligram per liter. So liter cancel, liter cancel. It will be 250 multiply 10 raised to power 6 milligram. Or you can say in terms of kg, you can convert 250 kg. So if 1 liter, if 200 ml sample consists x milligram suspended solids, we can say 1 liter sample will consist 5x milligram suspended solids. So concentration of suspended solids, concentration is mass by volume. Concentration of suspended solids is 5x milligram per liter. It means, what is the meaning of that? 1 liter sample consists suspended solids 5x milligram. And if you have 50 million liter sample of water, if you have 50 million liter water and you are going to find the suspended solids in that 50 million liter water, then answer will be 250 multiply 10 raised to power 6 milligram. You can convert into kg, kilogram. So answer will be 250 kg. Very simple. And that means if we report our answer in terms of milligram per liter, it makes our calculation easier. So that's why all the parameters are reported in terms of milligram per liter. Right? For water case, we also choose one another unit, ppm. ppm means parts per million. ppm means parts per million. So either you say 5x milligram per liter, or you can say 5 ppm. For water case, both are approximately same. Both are considered approximately same. Both are considered approximately same for water case, not for air case. Right? For air case, it is huge difference. It will create huge difference. But for water case, we can consider 5x milligram per liter. We can say 5x milligram per liter or 5 ppm. So the concentration of the suspended solids in the water, either you say 5x milligram per liter or say 5 ppm. Both are true. Both are true. So here, we measure the suspended solids by measurement. We measure the suspended solids by their weight measurement. So that's why we are saying it is the gravimetric technique. We are measuring the weight of the suspended solids and only then we are reporting our answers. So that's why we said here that it is the technique named as gravimetric technique. I hope it is clear to everyone. Right? Now sir, also we are interested in finding the amount of dissolved solids. Can we find the dissolved solids? Yes, we can find. We can find that dissolved solids. How? This filter, from this filter, as I told you, from this filter along with H2, dissolved solids also passes. So here we have considered one container, and in this container H2O plus dissolved solids are present. In this container H2O plus dissolved solids are present, and if we heat this sample that consists H2O plus dissolved solids, if we heat this sample, again we are heating this sample at 104 degrees Celsius. If we heat this sample, from the sample H2O will be evaporated and only dissolved solids remains left, and we can measure the weight of those dissolved solids, and let us suppose the dissolved solids having weight is Y milligram. We have measured the weight of dissolved solids, and let us assume the weight of those dissolved solids comes out to be Y milligram. So what we are saying, in the same sense 200 ml sample consists Y milligram dissolved solids. If 200 ml sample consists Y milligram dissolved solids, so can we say 1 liter sample will consist dissolved solids of 5 Y milligram per liter, as I discussed here in the same way? Yes. So 5Y, the concentration of dissolved solids we can write here. So concentration of dissolved solids we can say, I am writing here, concentration of dissolved solids we can say 5Y milligram per liter or 5Y ppm. Friends, this is basic concepts which I am telling you, very important concept, because in next classes I am not going to explain you every point in detail, because this point, if I told you that in detail that why we are reporting the concentration in milligram per liter and how we achieve this value, this is very basic calculation. In the first class we have discussed this, we have understood the concept. So in another classes, in next classes, it will be easier for us to clear the topic, right? So that's why I am investing the time for understanding this concept. So that's why I am taking that too much time, right? Okay. Now friends, also one more point is there. I am now interested in finding the amount of organic solids and inorganic solids. As I told you that solids are also classified on the basis of nature. Some solids are organic in nature, some solids are inorganic in nature, and I am interested in finding that how much amount of solids are organic in nature and how much amounts of solids are inorganic in nature. So how we can differentiate in that? So now listen, now what we do in that case, let us suppose suspended solids. We know concept is this suspended solids, among these suspended solids, some are organic suspended solids and some are inorganic suspended solids. Some solids are organic suspended solids and some solids are inorganic suspended solids. Now what is the value of that? What is the value of that? What is the amount of that? What is the amount of organic suspended solids? What is the amount of inorganic suspended solids? So in that case, what we do, now this suspended solid is taken into a device that is named as muffle furnace. Remember the device name, muffle furnace. This muffle furnace, friends, is a device in which temperature is kept at too higher, at elevated temperature we kept here, and here the temperature is around 600 to 650 degrees Celsius, but sometimes in exams 550 degrees Celsius is written here. So if 550 degrees Celsius is there, we will tick this answer. So what we do in muffle furnace, when we add the suspended solids which we have already got after the heating the residue, we heat our residue, the suspended solids are present here, we put out the suspended solids and we add into muffle furnace. So this suspended solids are added in this muffle furnace device, and here the muffle furnace, here the suspended solids, the temperature we keep 550 degrees Celsius or 600 to 650 degrees Celsius, and the temperature of the duration of this temperature is 3 to 4 hours. That means during this 3 to 4 hours in the muffle furnace, temperature will be in this range. And what happens during these 3 to 4 hours? All the organic matters oxidized. We are oxidizing the organic matters by heating the temperature, by heating the water sample, or you can say by heating these solids. In the suspended solids, whatever the amount of organic solids are present, all organic solids are going to oxidize. So when we add the suspended solids in muffle furnace, in this muffle furnace the suspended solids are present, and in suspended solids some organic and some inorganic. All the organic suspended solids are going to oxidize, friends. So when at this temperature all organic matters are oxidized. So here when all organic matters are oxidized, all organic suspended solids are oxidized, so that means after 3 to 4 hours the solids which are left in this device will be inorganic suspended solids. These are the left inorganic suspended solids. The solids which are left in the sample, in the muffle furnace, that are the inorganic suspended solids. And friends, we measure the weight of this inorganic suspended solids. Let us suppose we are measuring the weight of this inorganic suspended solids and it comes out X dash. We measure the weight of this inorganic suspended solids, and let us suppose the weight of this inorganic suspended solids comes out X dash. So friends, suspended solids we have X milligram, inorganic suspended solids we have X dash milligram. So organic suspended solids will be X minus X dash, yes or no? X minus X dash. We can find the organic suspended solids by this way. So organic as well as inorganic suspended solids, right? So remember this point, that at this temperature all the organic solids oxidized. Specifically the organic solids which oxidize at this temperature are termed as the volatile solids. Specifically, if I tell you that the organic solids which oxidize at this higher temperature are the volatile solids. So these are the volatile solids, and the solids which are not oxidized, which remains left in the muffle furnace device, so these are the non-volatile solids. If these are the volatile, then this will be non-volatile. What is the meaning of these volatile solids? Volatile solids means the solids directly converting into gases without coming into liquid phase. So basically in the muffle furnace, whatever the amount of volatile solids are there, those all volatile solids are going to oxidize. And friends, these volatile solids are organic in nature. So that's why we are saying these are the organic solids. So these volatile solids are organic in nature, so that's why we are saying organic suspended solids. So remember this point. So don't get confused. Either say organic suspended solids or volatile, both have the same meaning. Right? Both have the same meaning for this topic. So organic suspended solids and volatiles. So that's why we are saying that in muffle furnace, if you keep this temperature for this duration, all the organic suspended solids oxidized, removed from the device, and only inorganic suspended solids remains left. Or you can say all the volatile solids removed and non-volatile remains left. And these inorganic suspended solids, or you can say non-volatiles, are also termed as fixed solids. These solids are also termed as fixed solids because they are not oxidized, they are fixed, they are remains in the device. So we say it is the fixed solids. Sometimes friends, in the exams, nomenclature asked. Question says that how we differentiate fixed solids and non-fixed solids. Now you will say, sir, we have not read about this fixed and non-fixed solids. So friends, these nomenclature you have to take care. So remember, non-volatile solids, inorganic solids, or fixed solids. Remember the nomenclature, very important for exam point of view, right? Now further next point we have impacts of suspended solids in the water. If suspended solids are present in our water sample, what can be the impact of the suspended solids? We are saying that in our water sample suspended solids are present. What can be the impact of suspended solids that suspended solids if suspended solids are present in water? The very simple point, first point is very simple, that aesthetically displeasing. If I give you one water sample, if I give you 1 liter water sample, or let us suppose 1 glass water sample, and in that glass of water sample you are observing, sir, some particles are in suspension. You are seeing the particles are in suspension, suspended particles are present. Can you consume that water? Can you drink that water? No. That water you cannot consume. Why is it so? Because that first answer, that sir, that water is not aesthetically displeasing. That water is not aesthetically displeasing. How can I consume that water? Although it may be safe, it may not consist any harmful microorganism, but you will not consume that water because it is not aesthetically displeasing. Right? So first impact will be aesthetically displeasing if suspended solids are present in the water. Second impact, friends, if suspended solids are present, and we know that some suspended solids may be organic in nature. Some suspended solids may be inorganic in nature, and further these organic can be further biodegradable in nature. And friends, if biodegradable organic particles are there, it means microorganism will be there. And friends, if microorganisms are there, can you consume that water? Again you will say, sir, no. Why? If we consume that, what happens? Microorganism will enter in our body and waterborne disease will be there. Sir, which waterborne disease, due to which type of microorganisms, we will discuss in our biological quality parameter. That some viruses are there that will leads to the hepatitis problem, jaundice, and bacteria are also there. Due to the bacteria, cholera is there, and you can say typhoid is there. Right? So different type of microorganism, then different type of disease are there. We will discuss one by one. Right? So friends, second parameter, second impact is that suspended solids may be biodegradable in nature and may promote growth of pathogen. Pathogen means microorganisms which are responsible for waterborne disease. Friends, all microorganisms are not harmful for us. All microorganisms are not harmful for us. Some microorganisms are harmful for us, and those microorganisms which are harmful for us are termed as the pathogens. We will discuss it in our biological quality parameter, that which microorganisms are harmful for us and which are not harmful for us. We will discuss one by one. So in our water sample, suspended solids if present, these suspended solids may be of biodegradable in nature, and if these solids are biodegradable in nature, then what happens? Microorganism will be there, and if microorganism is harmful microorganism, that are the pathogen, and due to that pathogen, disease will be there. Right? We will suffer from the disease in that case. Another impact, that in our water sample, if this water pipe we have, because from a river to our community we are going to supply the water, and in this water pipe water is flowing and also suspended solids are present. What happens with respect to time? These solids will get deposited over these pipes, and if these solids get deposited over these pipes, that means deposition of solids is there, and this deposition of solid is termed as the incrustation. Deposition of solid is termed as incrustation, and if solids are getting deposited in the pipes, it is termed as the incrustation. So we will say that if suspended solids are present and the water pipes which carrying the water, and incrustation problem will be there. What happens due to the incrustation? Initially, let us suppose no incrustation is there, pipe carrying discharge, but when incrustation is there, pipe cannot carry same amount of discharge. So discharge carrying capacity will reduce, right? It will create a problem. So it leads to incrustation. Incrustation means deposition of solids in pipes, hence reducing discharge carrying capacity. Reducing discharge carrying capacity. Next impact, what can be the other impacts also? Friends, in our water sample, for in a treatment plant, we do some treatment. One of the treatment named as the disinfection. I hope everyone is aware about the disinfection. Mostly chlorine is used for the disinfection in Indian continent, right? In our country, right? In European countries, you will use like some other disinfectant, like ozone treatment is there. And also I will tell you that what are the disadvantages of ozone and what are the advantages of ozone, and other disinfectant agents like potassium permanganate is there, chlorine is there, right? So which disinfectant is used in which situation, I will tell you. But here let us suppose in our water sample I am adding the chlorine. Why I am adding chlorine? purpose of adding chlorine is to disinfect the water. What is the meaning of disinfection? To kill the microorganism. In our water sample, microorganisms are present, and to kill those microorganisms we are adding chlorine. Chlorine will remove those microorganisms. Chlorine is disinfectant agent. So chlorine kill microorganism. What is the mechanism of chlorine in the killing of microorganism? We will discuss later on. That mechanisms also asked in the question. So when we add chlorine in our water sample, why we are adding chlorine? To kill the microorganism. Now what happens? Here microorganism is present, and around this, and suspended solids are also present. And what happens? Suspended solids are present around these microorganisms. So what happens? If around these microorganisms suspended solids are present, so we are saying that suspended solids creating some shield around this microorganism. And when this shield is being formed by suspended solids around these microorganisms, now you have applied chlorine to kill this microorganism. This chlorine cannot reach to this microorganism, and if this chlorine, friends, not reaching to microorganism cannot be killed. It means effectiveness of the chlorination is reducing. Efficiency of the chlorination is reducing. So it means if suspended solids are present in our water sample, it will reduce the efficiency of the chlorination. Right? So if we want to remove this microorganism also, we have to add more and more chlorine. So that means in that case cost of chlorination comes out to be more. So basically presence of suspended solids is going to interfere with treatment of the water. So here suspended solids interfere with treatment of the water. How? By increasing cost or reducing the efficiency. So these are the impact of suspended solids, friends, and very important because question asked from this impact. I hope it is clear to everyone. Now some questions we are covering here. Some questions we will discuss. First question is saying, according to the notes, which Indian standards code is referred to for drinking water? Right? According to the notes, तो गलत है. This is not here. Right? Just simple tell us which Indian standard code is referred to for drinking water. What is our drinking water code? So friends, our drinking water code is 10,500. As I told you, our drinking code is 10,500, 10,500. Second, what is the term used for water that is not chemically pure but contains nothing harmful to human health? And that water is known as wholesome water. Right, friends? Physical quality parameters are defined as those that can be sensed by any of our senses. I told you, physical quality parameters, those parameters which indicate physical quality, and the physical quality which can be sensed by any of our senses. Which of the following is an example of inorganic suspended solids? So first you will identify the suspended solids, after that inorganic. Right? Inorganic suspended solids. Algae is the organic suspended solids. Plankton also organic in nature and its suspension. So organic suspended solids. C6H12O6 glucose. It's a glucose. C6H12O6, it's a glucose. It is the organic dissolved solids. It is in dissolved form, na? So it is organic in nature, dissolved solids. Calcium carbonate is inorganic suspended solids. Other examples I have discussed already. Which of the following is an example of organic dissolved solids? So organic in nature and dissolved form. C6H12, it's H12. C6H12O6. It is the organic dissolved solids. Magnesium carbonate, inorganic dissolved solids. No need to remember this. As the topic continue, as we will discuss chemical quality parameter, so these entire solids we can learn very well, very easily, so, because these terms will be repeated. These terms will be repeated again and again. We will repeat these terms. Magnesium carbonate, sodium chloride, silica dioxide. This is the inorganic suspended solids. Sodium chloride, it is the inorganic dissolved solids. Right? Now, what technique is used for the measurement of suspended solids? Gravimetric technique. Gravimetric technique is used for the measurement of suspended solids. To measure organic suspended solids and inorganic suspended solids, the sample is heated in a muffle furnace. We are measuring organic suspended solids and inorganic, as we discussed just now. So in muffle furnace, temperature is kept around 600 to 650 degrees Celsius for 3 to 4 hours. Duration kept for 3 to 4 hours. Which of the following is not listed an impact of suspended solids in water? Which of the following is not listed as an impact of suspended solids? So due to the presence of suspended solids, aesthetically displeasing, yes. Incrustation is pipe, yes. Interfere with water treatment, yes. Chlorine efficiency reduces. Increase dissolved oxygen. If suspended solids are present in our water sample, dissolved oxygen is not going to be increased. I will tell you later on that if this suspended solids is of biodegradable in nature, and it will reduce the dissolved oxygen, right? I will tell you later on. So next, as per the EPA, now this point friends, as per the EPA, Environmental Protection Agency, suspended solids in water should be less than 30 milligram per liter. This point is written here that if we talk about the limits of our parameter suspended solids, IS 10500, all the limits should be according to IS 10500. But this 10500 code is not giving the limit for suspended solids. But in the different exams, question is there that what is the limit of the suspended solids. So the answer is 30 milligram per liter, but this answer is not as per IS 10500. This answer is as per EPA, Environmental Protection Agencies, or you can say Environmental Protection Act. So this answer is according to environmental protection. But question is specifically say what is the limit of suspended solids according to IS 10500. So the answer will be no, nothing mentioned. Nothing mentions, right? If option A, option B, option C, something values is there, and option D is none of these, then click this none of this. If question asks what is the value of suspended solids according to IS 10500, but if no code is mentioned and a suspended solids is going to be asked, then answer you can say 30 milligram per liter if it is in the option. If 30 milligram per liter is not in the option, then answer again none of this. So as per the EPA, and remember this, it is not specified in IS 10500, right? So this is the question friends here. As per the EPA, suspended solids in water should be less than 30 milligram per liter. Remember this point. Non-biodegradable organic matter is characterized by non-biodegradable organic matter, that organic matter which cannot be decomposed. So easy decomposition, no. Non-biodegradable, because bond energy is high, they cannot be easily decomposed. Low bond energy, no. High bond energy and cannot be decomposed by microorganisms. Presence of only carbon and hydrogen. Only this written word is only wrong. Non-biodegradable also, this is also the organic matter, and it also consists carbon, hydrogen, oxygen, nitrogen. But it is saying presence of only carbon and hydrogen, it will make this statement wrong. Yes. How does the presence of suspended solids affect water treatment process? If suspended solids are present in our water sample, how it affects our water treatment? It reduces the treatment cost. No, it increases the treatment cost. We have to add extra chlorine. It improves the treatment efficiency. No, it reduces the treatment efficiency. It has no effect on treatment. No, it has effect on treatment. It interferes with treatment by increasing cost or reducing efficiency. Yes. And efficiency of what? Efficiency of chlorination. Efficiency of chlorination. So friends, these are the some questions regarding our topic. This color topic also I want to cover it, but time already is 1:20, so I have taken too much time for only just for understanding the concept, right? So friends, just I am completing. I'm not going to cover this topic right now, right? So this will be covered in our classes. We will cover this topic in rest topic we will cover in classes. Again friends, last point, that if you have any query, you can discuss us, you can contact with us. Module already launched, classes already started, and from next week we are going to increase the duration of the classes, because we are going to cover entire syllabus in these given durations. So we have sufficient time and we can complete entire syllabus. So it's only up to you, because 19 vacancies are there and it's a good number of vacancies. If you compare with other states, so it is good number of vacancies in Pollution Control Board. So right, just you have a sufficient time, you can prepare. So again, any doubt if you have, you can contact us. Okay, thank you everyone.